mysterious planet has piqued the interest of scientists and space enthusiasts alike. Our closest cosmic neighbor, the exoplanet Proxima b, has been one of the biggest questions in astronomy. We knew it was there, orbiting a star just over 4 light-years away. So close, but still impossibly far. We've all imagined what it could be. Another Earth, maybe a water world, or just a barren rock. But we've never really seen it, until now. The James Webb Space Telescope just announced the clearest image of Proxima b seen in history. But what does that really mean? What secrets does this distant world hold? Let's have a look into what the James Webb Telescope just revealed. This isn't a simple photograph like one you take on your phone. It's something much more complex and honestly, much more exciting. It's a picture painted with data, with light, and with heat, and it's forcing scientists to rethink everything they thought they knew about finding life beyond Earth. To really get why this is such a big deal, we have to go back to the beginning. Proxima b was first confirmed back in 2016. It was a huge win for science, finding this tiny Earth-sized world hiding in the glare of its star. It was the discovery of a lifetime. A planet right on our doorstep, orbiting in its star's habitable zone. That's the so-called Goldilocks zone, where things might be just right for liquid water. The discovery sparked a ton of excitement. Could this be it? Our first real shot at finding a habitable world? The questions came fast. Does it have an atmosphere? Does it have oceans? Could it actually harbor life? But there was a huge problem. Proxima b is incredibly hard to see. It orbits a red dwarf star, Proxima Centauri. Now this star is small and cool compared to our sun, but it's also furiously active. It's known for unleashing powerful stellar flares that are thousands of times stronger than anything our sun throws out. Imagine a star that's just constantly screaming radiation at its closest planet. On top of that, the planet is practically hugging its star. From where we are, it's totally lost in the blinding glare. For years, telescopes like Hubble could only guess it was there. They couldn't see it directly. It was like trying to spot a firefly next to a giant searchlight from miles away. We knew the firefly was there, but we had no idea what it truly looked like. And that's where the James Webb Space Telescope comes in. JWST isn't just another telescope. It's an incredible piece of engineering that can see heat and look back in time. It was built for exactly these kinds of challenges. Sitting 1,000,000 miles from Earth, away from the blur of our atmosphere, Webb sees the universe in infrared light. And that is the key. Infrared is the light of heat. Everything in the universe gives off a thermal glow, and by seeing in infrared, JWST can pick up the faint leftover heat from a distant world like Proxima b. It's a signal that's completely invisible to other telescopes. More importantly, Webb has something called a coronagraph. Think of it as the most advanced sun visor ever built. It's a tiny mask inside the telescope that blocks the light of the star, which lets the incredibly faint light from an orbiting planet finally shine through. This is what makes it possible to study a world like Proxima b in such detail. For years, Proxima b was a puzzle without a solution. JWST is the solution. It has the power and the tools to cut through the glare and start painting the first real picture of our neighbor. And that picture is finally starting to come into focus. So what is Webb looking for? The first and most important question is whether Proxima b even has an atmosphere. A planet that close to its star could have had its atmosphere totally blasted away by those violent flares a long time ago. Without an atmosphere, you get no pressure, no weather, and no chance for liquid water. It would be a dead world. This is where one of JWST's key instruments comes in. It's a spectrograph, which doesn't just take a picture, it breaks down the planet's light into a rainbow called a spectrum. Different molecules in an atmosphere, like water, carbon dioxide, or methane, leave a unique chemical fingerprint in that light.
Scientists are pointing Webb at Proxima b to look for these fingerprints. The main target is carbon dioxide. Finding a real CO2 atmosphere would be revolutionary. It would mean Proxima b isn't just a barren rock. It has a climate. It has weather. It has the basic building blocks that could make it habitable. Now, the ultimate goal is to find biosignatures, the signs of life itself. Here on Earth, life creates a mix of gases like oxygen and methane. Finding that kind of combination on Proxima b would be one of the biggest discoveries in human history. But the picture Webb is revealing isn't all sunshine and roses. While an atmosphere is a good sign, there's a terrifying catch. Proxima b is likely tidally locked with its star, which means one side is always facing the star in scorching daylight, while the other side is frozen in endless night. The best place for life might be in the Terminator zone, a ring of permanent twilight between the hot and cold sides where temperatures could be just right. But you might be thinking, what about those flares? The planet is under constant attack. As a recent study showed, the solar wind hitting the planet is roughly 1,000 times stronger than what Earth gets. A flare spotted in 2021 was 100 times more powerful than any flare ever seen from our own sun. Any life there would have to survive radiation that would be instantly lethal to us. It raises a tough possibility. Proxima b could have all the right ingredients for life, but be constantly sterilized by its own sun. This is the central drama of Proxima b. It exists on a knife's edge. Does it have a magnetic field strong enough to protect it? Could a thick atmosphere spread heat around the planet? These are no longer just theories. They are puzzles that JWST is giving us the pieces to solve. This brings us back to that title, the clearest image in history. It's really important to understand that this image is not some high-def photo of continents and oceans. Even with JWST, we can't see the surface of a planet 4 light-years away. You could fit thousands of Proxima b's into a single pixel of a Webb image. So what is this image? It's a map of heat, of chemistry, and of light. By using its instruments, JWST can detect thermal emissions from the planet. It can see how heat might be distributed across its surface. And this is where the real science begins. Could we use that data to see the thermal signature of vast oceans absorbing heat differently than land? Could we see evidence of widespread volcanic activity? These are the kinds of questions scientists are now able to ask. This is the true power of JWST. The clearest image isn't one we see with our eyes, it's a multi-layered, data-rich map that scientists are decoding. We are, for the first time, moving past just guessing and starting to actually map the geography of another world. As humans, we've always been fascinated with what's out there, and the story of Proxima b is modern exploration at its finest. We're standing on the shore of a huge cosmic ocean, and with the James Webb Space Telescope, we finally have a ship to explore the nearest island. This image, made from infrared light and complex data, tells the story of a world of incredible extremes. A world with the potential for water, but one that is constantly being battered by its star. It's a world of amazing clues and deep mysteries. We haven't found proof of life. We haven't seen alien cities. What we have found is something just as important: a path forward. We now know the questions to ask, and we have the tool to find the answers. The search for life on Proxima b has officially begun. If you've enjoyed this video, be sure to hit that subscribe button. And if you're as fascinated by space exploration as we are, then you won't want to miss a single episode. So while you're here, be sure to check out the video on your screen for more mind-blowing insights into the mysteries of the cosmos. What do you think JWST will find on Proxima b? Let us know your thoughts in the comments below.